Now entering the Bitcoin Podcast Network.
Welcome to Hashing It Out, a podcast where we talk to the tech innovators behind blockchain infrastructure and decentralized networks. We dive into the weeds to get at why and how people build this technology and the problems they face along the way. Come listen and learn from the best in the business so you can join their ranks. All right, episode 32 of Hashing It Out coming at you. As always, I'm Dr. Corey Petty with my trusty co-host, Colin Couchet. Say hello, everyone.
Hello, everyone.
All right, well played. Today, our episode is with Grid Plus. I have Karl and Alex with us to join us to discuss all things Grid Plus and crypto on a technical side, what problems exist, etc. Why don't you say hello, give everybody kind of a quick introduction as to, as always, where you came from, why you're in the space, and what problems you're trying to solve.
Hey, this is Alex. So I got really interested around 2015. I'd been introduced actually by Karl before that, but I read up on Ethereum as it was sort of launching, and I got really interested in what that was sort of bringing to the space. I was working at a fintech company and was working with a traditional payment processor, and I was very frustrated with it. It was very difficult and expensive, and I thought that this could solve a lot of problems in that space. So I kind of started developing, never looked back, joined Consensus, was working there for a while, and then we spun out into Grid Plus, where I am now.
Yeah, so this is Karl. I got interested in crypto back in the 2012 timeframe. I was in graduate school at the time, working on a doctorate in material science. Number of times during graduate school, I was thinking to myself, maybe I should just quit and go do crypto full time. But in like 2013, 2014, it was pretty tough to find employment in the space. So, as fate would have it, I introduced Alex during graduate school to cryptos. He ended up getting a job at Consensus eventually after he graduated. And then he was working on some energy projects, and I had some, experience and expertise in the area. So I ended up getting a job working at Consensus, and then eventually we came up with the idea of Grid Plus, and we spun it out as a company. So now we're Grid Plus, and Grid Plus, just a quick introduction there, I guess, is the world's first blockchain-based electric utility, and our customers will eventually be able to buy, sell, and settle their energy in real time using blockchain. So a lot of the problems we're working on is how to actually use blockchain for a very practical application, but for an application where you're actually having to interact with, the average sort of layperson. So we're building a set of hardware and software interfaces that abstract kind of crypto out and the security associated with crypto, such that the average person can kind of interact with it easily and seamlessly without not really needing to know kind of what's going on under the hood. So
that is what I would call a very difficult but necessary thing to do in this space, and that is a ridiculous mug that you just put up. Your unicorn mug with rainbows and such on them. Very appropriate for the space. But in my experience so far, and how I've kind of thought about this, is that we can build all these cool technology in the space, but it's so drastically different because people are responsible for maintaining these private keys and passwords and things. And as we've seen, at least in the security field, everyone is really shitty at handling passwords, especially when they're really long and are associated with money. And a part of what you're trying to do is abstract that away, like you just said. How do you do that so that people can have all of the benefits of handling their own wealth and assets, digital assets, but also like not force them to be incredibly educated and understand all the cryptography and whatnot.
Yeah. So, I would 100% agree with you in terms of, the difficulty associated with this and sort of the average understanding of security, right, by the average person and kind of how they interact with it and how that would be dramatically inadequate for dealing with any form of digital money. The interesting thing that we've kind of come to is that what it really comes down to, right, is storing a secret in physical space as we see it. And there's an example of how that's actually done well for the average person currently, and that's payment cards, right? So when you look at payment cards and you compare those to blockchain, sort of how they work, chip-based payment cards and how a blockchain works, it's very, very, very much analogous, right? I mean, they're both, private keys on the cards that make signature when you put them in a terminal to sign a transaction that then gets broadcast to a network. In one case, it's, say the Visa or MasterCard network. In another case, it is, it's a blockchain, right? So the solution that we're developing is actually called the Lattice One from the hardware standpoint. And it's kind of like your sort of crypto bank, right? It looks a lot like kind of like a point of sale terminal, but it's one that you would have and own at home. So it has a native account on it. But it has a secure interface so that you can interact kind of with the account that's in the device. The device itself, does a lot, and we can get into it in terms of how the hardware interacts with the security model, but you have the secure device and you're able to interact with it. And then we also have the cards, which you can then use to create like many accounts. So instead of just having one account on one device that, you could lose or break, you can back those accounts up on pin or chip cards. You can, do like a 2 or 3 multi-sig. You can do hierarchical multi-sig. So you can do like a 1 card backed up by 3 cards sort of thing, but it all interacts kind of with that lattice. And then the lattice is cool because it allows you to then create permissions for different types of payments based off like who's requesting it. So you can pair it with a device or a service. So a device would be like an app. So we have what we call our mobile pay app. And that pairs up with the lattice. And then when you make a request from the mobile pay app, it has to pass a permission, which is enforced on the lattice. So you could say your permission is, $200 per day to any, payee. And as long as that request passes, the lattice will then sign and send that transaction back to your mobile pay app. So the mobile pay app itself isn't like handling keys because it's not a good environment for handling cryptographic, money signing keys. All of those are in the lattice, and then the lattice actually does the signing. In terms of a service, what it looks like from a point of view of Grid Plus is you could pair with your service provider, Grid Plus. Your lattice would sit there, and when Grid Plus makes a request for payment, again, you'd have a permission that says Grid Plus can charge me $100 worth of energy per month, right? And as long as that request is under your permission, the lattice will then sign and send the money back to Grid Plus. So it also creates sort of this topology of being able to do permission payments, but also automatic payments. So you can kind of deal with bills from service providers, kind of how you deal with them now, where you just set up your Verizon account, you put it on a credit card, and it just automatically pays it every month.
What's the resolution of that? I'm kind of curious because one of I think with the interesting technological benefits of using cryptocurrency is the idea of streaming payments. So do you have permissions resolution where you can say like you could charge this amount of cents or this amount of crypto per minute or per second or something like that?
Yeah, so we allow you to set up many permissions for many different time periods, and they're sort of aggregated together. So I could say on my mobile pay app, I could do $200 per day or $1,000 per month. You could take that down to second level permissions. Obviously, the issue with doing that is the fees on the network, which you can get around if you do a payment channel. And there's some other interesting ways to do it that we haven't really talked about in public,
Yeah.
but there's other ways to go about it as well.
One thing I'd like to add is when you talk about the fees kind of adding up if you're doing micropayments, we've designed this permission and signing system. So if you think about the Grid Plus Lattice, what we'd like it to be is an out of the box, just like storage facility for all of your secrets and sort of a stateless signer. So it itself by default doesn't have a concept of like what the blockchain state is. And that's because we want it to be blockchain and really signature agnostic. So if you look at something like an emerging standard like Lightning, right? So that's a different transaction schema than you would have with normal Bitcoin, definitely different than you would have with Ether, right? So we have set this up to sort of sign against a predetermined set of schema. So one would be an Ether transfer. And in that case, you would have like an Ethereum transaction with the data field being blank. You could do an ERC20 transfer, which would have sort of a pre-configured, data hex field that would facilitate the transfer of an ERC20 token. And then you have something similar for Bitcoin. And in the future, we could add Lightning if there was another sort of payment channel network and protocol that emerged and was gaining market share. We could easily add that. So what we've done is we want this to be extremely abstractable. And we have an SDK that pairs with the device that is available, although you can't use it because I haven't released the device yet. But what that'll do is it'll basically, when you're defining the permission, you say basically what type it is, and that relates to the schema.
Yeah. So just to kind of add on to that, so the reason we have schemas is that, right, you can have like your key be perfectly secure, but if I can get you to sign something that you didn't intend, that's just as bad as me getting your key. So the schemas are the mechanism by which the user defines a permission, and the permission then is checked against, or a request is checked against that permission based off that schema, right? So because if I just sort of like send down hex to people, or hex into the enclave to sign the transaction, and I don't check that hex before signing it, I could sign anything, right? So I didn't reveal the public key, but maybe I, permuted the transaction and generated a new payload to sign, which was taking all your money. So that's kind of the mechanism, and the reason that you need the schema is to be able to check what's actually getting signed.
Yeah, I got my hands on one of these things at DEF CON when we talked, and something you said kind of really hit me home, and the way I see this whole space moving forward is it's literally a personal HSM, or hardware security module. So it's the right way to store very, very secure things for crypto, like private keys, and has a hardware solution for doing very configurable signatures and things like that, the types of operations you do with cryptographic assets, as well as a permissions layer that sits on top, and that's also highly configurable. And that's kind of what you want. And so you can have, and then this also allows for things like multi-factor authentication for different permissions, and allow you to treat different accounts with different levels of like accessibility and withdrawals and all that kind of stuff. And I see that's going to be very, very necessary, because people can reason about how they want to spend their money, what they think is valuable, and who should have access to it. But they shouldn't have to learn very odd signature schemes and different types of software to do that themselves and all that stuff. And so I think this is that's why I'm so like, I like this project so much, is because the devices like this, I think, are going to end up being ubiquitous now that we've kind of unleashed the idea of digital assets, like permissionless digital assets.
I certainly hope they become ubiquitous, because there's really kind of like two paths, right? When you think about what cryptocurrencies have done, it's disintermediation, and at the broadest level, and you could argue it's disintermediation of the monetary authority, right? So like the central bank issuing currency. When you start talking about disintermediation at the lower levels of your low value added intermediaries, to actually get that disintermediation to happen, people have to actually be custodians of their funds, right? So it would be a sad story in crypto if we end up with crypto becoming ubiquitous. But to do that, we've replaced J.P. Morgan Chase with Coinbase, or Coinbase. Yeah. We just have a new form of a bank basically. So we've maybe removed the money from the central bank, but we still have banks and we still have intermediaries and we still have middlemen. But now we have it on this public ledger that's like very traceable. And so in some ways it's potentially worse than kind of what we have now because there's some sort of solid degree of privacy, arguably. But
I've said this a lot. I mean, this is something I've tried to harp on a lot of people is that when you decentralize everything and remove these intermediaries, you push the risk onto the people who are now responsible for this information. If you're going to hold your own value and manage it yourself and not offload that responsibility to somebody else, you also have to handle the security and the risk associated with it. And we, as people building things, have to provide tools that allow them to make good decisions on their own. If they can't do that, then they can never handle the risk associated with the value that they're holding, and they won't ever do it. They'll just use intermediaries like Coinbase. And so, you can't have this ideal dream that blockchain started, kind of the idealism that started Bitcoin in the first place, until you have tools and devices available so that people can make better decisions. And I think this is one of them.
Yeah, I mean, and we absolutely see that, and that's really kind of what we're trying to address, and that's really our hope, that this is demonstrating at least one solution for kind of how to get your parents a mechanism by which they can understand but use to deal with blockchain-based assets.
Now, Grid Plus when you even said it earlier, it's been kind of a decentralized marketplace for energy. And we haven't talked a lot about energy up to this point. What exactly are you doing in that space? And why did you choose Texas to be the home base for that space?
Yeah, so originally when we came up with Grid Plus, right? Grid Plus is this idea of blockchain energy. So when Alex and I were at Consensus, we were working with some large energy companies doing proof of concept demonstrations of trading energy on a blockchain. What we realized from doing those was that all of the energy companies kind of wanted to take a top-down approach. So they wanted to say, hey, we're the big players. We have these big trading desks. We're going to create a proof of authority chain, and we're all going to kind of do a demonstration to settle these things. They would create these very siloed environments, and they were sort of reluctant to use public blockchains. But once you get off a public blockchain, you arguably aren't really settling value anymore. Once you're not settling value anymore, then what are you doing? Replacing
bookkeeping. Just bookkeeping.
Yeah, it's just bookkeeping, and you don't need the blockchain at that point to do it. You could use other solutions like databases, right? So we were looking at that and we're saying, okay, how will this actually sort of get adopted? And the road looked very long, big companies, big changes. You're talking about decades or more. So the way that cryptos kind of work up to this point is it's not some big company comes in and says, here's how it's done. It's always a grassroots thing. You're always, starting from the lowest level, and that sort of gains mass, and then you get sort of higher applications of higher value with more people, and it's a grassroots thing. So looking at the energy market, the grassroots thing is, instead of starting at the biggest players your trading desks of your large energy companies, you start with the consumer, and the consumer is getting marked up in the chain of actually getting their electricity. So if you start at the consumer and you use a blockchain and you give them better access to the markets, you can get rid of all of that markup, and you can provide them better service. So they're a good sort of point to start, and it's also a low sort of risk point to start. So in Texas, it's a deregulated market. We didn't need to go and get buy-in from the state and the legislature and all these things. We can just start a rep work with a retail electric provider, work within the existing rule sets and start doing crypto-based payments and settlements, right? The issue that you get when dealing with the individual, though, is how do you, have that individual be able to deal with, crypto-based assets, and how do you do it in a way that it's automated, right? Because you don't, if a residential customer can pay for the electricity, but it's like, hey, man, they got to like get MetaMask out pay a bill, they got to, get their ledger out and do that. I mean, that's obviously not going to work at any meaningful level. So, very early on, we knew that there was a need for an endpoint for storing and dealing with the automatic payments and storing the cryptos, which we called the agent over a year ago. We call it the Lattice one now. So to kind of give you an idea of where we are on the energy business, we are a retail electric provider in Texas. We are serving around 20 customers right now. It's kind of like our friends and family. Within the next few weeks, we're going to be rolling that out to beta. So a number of people, a few hundred or more, have signed up on our mailing list. If people are interested in Texas in a deregulated region, Encore or Centerpoint, they can go and they can sign up, and we'll open that up, and then we'll start serving those customers as well. So the first thing that we're doing is, delivering electricity and then allowing customers to pay monthly with crypto. Then once the Lattice rolls out, that'll become an automatic payment. And then sometime next spring, we'll start to shorten the interval that you can pay on. So it'll start turning into a more apparent real-time payment. So the market in Texas is a deregulated market, which is one of the reasons we picked it. It also has 15-minute intervals, so it operates in kind of this real-time increment or near real-time increment. And then finally, smart meters are ubiquitous in the state of Texas. So in terms of getting the data that you need to do the settlement, that's also there as well. So those are kind of the reasons we picked Texas.
And Texas is awesome.
Smart meter, because I think a lot of our I think a lot of our audience doesn't know what you mean by when you say smart meter. What does that mean? And like, is it a more decentralized way of running the power grid? Like, how does this work?
Yeah, so a smart meter is basically a meter that reads your usage electronically and then has a mechanism for communicating that back. So in Texas, there's two different ways to deal with like communicating that back. The TDSPs, or transmission distribution service providers, have a mechanism which they call a backhaul. So it's this proprietary RF mechanism. It doesn't have incredibly high throughput, so they only get reads maybe 4 times a day. The other mechanism to do it by is something called HAN, Home Area Network, which is just a name for a Zigbee interface on the meter. So the Lattice actually has a Zigbee antenna, and we'll be integrating those with the meters such that the Lattice can actually ask the meter what its usage is kind of all the time. And then based off that usage, it'll decide, okay, how much, it'll communicate that back to Grid Plus. Then Grid Plus will say, okay, pay me, that number. And then when we get numbers back from the TDSP, maybe a day later, there'll be a sort of reconciliation true up, but it should be pretty accurate, in real time. So yeah, that's a smart meter. And in Texas, the Texas legislature kind of had this, it was pretty forward-looking vision. In 2007, they passed these rules that basically said everybody should have a smart meter. We want to run the market on a 15-minute basis, and we want it to be perfectly deregulated. So they're trying to set up like an efficient, competitive clearing market for electricity. And that's really why Texas was such a good choice.
Yeah, that leaves you guys really ripe with opportunity for your appliances. So that's pretty cool. But what can you do with your appliance that you couldn't possibly maybe do with just something that resolved to fiat?
Well, so there's a couple things. So the first one is this idea of capital and credit. So in the market, you have the REP, the retail electric provider. So Grid Plus is a retail electric provider. They provide access to the wholesale market for the consumer. And you typically do so on a 30-day use plus a 30-day net basis. So the rep is floating the customer essentially 60 days worth of credit, and they're having to place that capital because they're settling every day in the market. So there's a non-zero expense of that. There's also this concept of hedging. So most contracts are fixed price. So it doesn't really matter what you use. They're going to pay a certain, number of cents per kilowatt hour, regardless of what the market is doing. So what this allows is two things. One, if you can compress the payment interval, you can remove the need for capital and credit because you're actually settling in real time, and that allows you to pull, expense that you're passing on to the customer out of their bill. The next thing that you can do is you can give the customer the opportunity to more directly participate in the market. So if they have a lattice and they decide to use that to hook up to their Nest or, some smart thermostat or dispatchable load, like the two biggest loads in Texas for a household are going to be their HVAC system, so their thermostat, and their pool pump. So if you have a lattice, you get a thermostat for a couple $100. You get a switch put on your pool pump for like $30. You can control almost half of your load. So then instead of doing a fixed price contract, you can tell your lattice, hey, here's kind of like my opportunity cost. In some sort of easily understandable, abstracted way. Maybe it's like, I'm an eco consumer, I'm a value consumer, and I'm a comfort consumer, right? So based off kind of how you set your preference, it would dispatch those loads depending on the market price. So what really happens in the market is, a megawatt hour can clear anywhere from, negative up to $9,000 per megawatt hour in a given interval. I mean, typically it's, maybe 30, right? So you can get a lot of like volatility in the market during certain times of the year. So depending on how you set your settings, you could say, okay, the market price is going up. I'm now going to be responsive to that market price. I'm just going to turn my thermostat off for the next 15 minutes. I'm going to turn my pool pump off for the next 15 minutes, and I'm going to mitigate my risk. What that means from a consumer standpoint, though, is if you can run on a real-time price and you can just chop the volatility out of it by turning off half of your load when that happens, you'll get by far and away the cheapest price in the market that you could discover in any other way. So, I mean, to give an idea, right, if you're running a real-time product and you're doing dispatching in a lucky year, so to speak, you'll save another 40% on real-time over anything that we could offer in a fixed price.
I think it's something that is relatively normal, or this monthly payment scheme that we've become accustomed to. And the reason for that is basically because like the real, like we'll just take the energy market as an example of this because it's a wonderful one. The way the energy grid works is incredibly dynamic in terms of like demand and supply. And the cost of energy, it fluctuates quite a bit, like you said, the market. And so we didn't have the infrastructure for people to participate in that previously. So we had to build these intermediaries to kind of absorb that dynamic activity and then offer a consistent price to the end consumer, because there was no way for the end consumer to navigate that or like, and so based on that infrastructure, we've just become accustomed to monthly payments. But that payment gets kind of artificially inflated because that intermediary has to have operational costs. There's an overhead associated with doing that type of stuff. Like all the stuff you just basically detailed for us is why they can charge more. And now that we're able to like build new technology that enables us to build newer dynamic infrastructure and allow people to directly participate in that market, we no longer need the intermediaries. And so like I see this as a kind of a underlying theme in a lot of the blockchain space is getting rid of the intermediary, because we can now participate in dynamic markets automatically as an end consumer. And we no longer need someone to negotiate that for us and then pay them to do so.
Yeah, exactly. I think in this particular case where you kind of have this like transactive sort of, a transaction-based intermediary, if you will, the only way you can actually achieve that, though, is through custodianship still.
Yeah, right? Like smoothing functions for people.
Well, correct. But like we can't achieve any efficiency unless the person is the custodian of their assets and they're able to have access and usability of those assets. So if I put them into like a bank situation, what we're going to end up doing is we're going to create, that bank intermediary that's going to charge us fees for every transaction and a percentage. So we're going to kind of, maybe we'd be a little bit better, but we're still going to be not in an ideal situation because we're still going to have that intermediary between the actual producer of the good and the consumer of the good. So yeah, I mean, it's definitely a theme, and the real, I think, need to make that theme realized is that custodianship solution. So if you want to kind of like generalize what we're doing, we're kind of building what I would call a repless rep, right? So we're a rep, but our goal as a rep is to like not be a rep.
Your job is to make your job obsolete almost.
Yeah, correct. And you could think about that with other systems, like a super obvious one to me is like creating a carrierless carrier. So a wireless carrier, if you kind of understand how the infrastructure works, you understand how sort of bandwidth agreements work. It's a very similar model to the energy business. And if you create that custodianship solution, you could actually have a phone where you're just bidding for the cheapest tower, or maybe it's not even a tower, maybe it's a Wi-Fi connection, or it's something like that. So you're finding sort of in real time the cheapest counterparty to deliver the service, and that's enabled by having that standard blockchain to let everybody interoperate.
Jeez. So something that I haven't heard you talk about is you've released a token, and you're funded through the ICO, I believe. So what are your intents for the token and the ICO?
Yeah, so the tokens are basically a coupon, and the coupon is redeemable for 500 kilowatt hours of electricity at essentially the wholesale cost. So zero markup between the wholesale cost and the cost that you're paying. So basically, even if we're a repless rep, we still have overhead. So we have to mark up a little bit, but it's less than obviously a traditional rep would mark up. So with a token, you're getting basically the lowest sort of market discovered price in the wholesale market.
And so this would only work for people who have Lattice installed in their house and have it hooked up to their system. So right now, it's not really viable because you're only kind of in the early alpha stages, and then you're going to get into beta.
So the alpha customers have redeemed Grid, and so you can redeem it on a fixed price rate too. So we'll take the average of sort of the wholesale costs, and we'll deliver that price to the end consumer. So you don't have to have a Lattice to use Grid tokens. You could be on a fixed price contract and you could still use Grid tokens. In terms of kind of like other uses, we are planning, it's not certain at this point, but we're planning to also let people use the Grid tokens to get a discount on the lattices themselves. So there's a number of different use cases. The current one is basically getting cheaper energy in Texas.
And you burn those after use, right?
Correct.
Yeah. So that, like, eventually there will be no more token.
Correct.
Yeah. I remember hearing that, I think the first time we interviewed a long time ago on Block Channel or something.
So
go ahead.
You have all these devices and they're communicating all these transactions. How do you know what device is making that transaction? Can you marry these transactions to the devices? This is more of like a technical question. Like, how do you know what did what necessarily? I mean, you have one user with like an identity, but is there a way to tie it down to the device level, or is that something that's not necessary for this scheme?
So in the context of Grid Plus, the retailer, we are only concerned, if we're talking about crypto payments, we're only concerned about who's sending payments to which recipient address. So what we would do in the case of the retailers, every customer has one or more receiving addresses, and we're basically watching those. So, and then if we migrated to a payment channel, it would be kind of the same deal. So with a device, you would typically, I guess we haven't talked about this. So the way that you kind of set up your device as a consumer, this would be both on the energy side, and then also we will sell these as standalone devices that'll come with, a mobile wallet. So you have an app, and in this case, it would be the mobile wallet. That would be the first kind of app out of the gate. And the first step to getting set up would be to do something called pairing with it. And this is basically a Diffie-Hellman key exchange. You generate a shared encryption key and are able to communicate with the device. And once you can communicate with the device, you can request addresses, and you can request signatures using those addresses. So the keys never leave the device, but the addresses will be basically received by paired applications, if that makes sense. So in the future, what you could do is the purpose of the SDK really is that you could have many apps that pair to your device. And the way that they would discover that the device is via a serial number. So you would basically load up your app as a user and as an owner of your device. You would type in your serial number. It would basically use a cloud proxy, kind of similar to discovery nodes in a peer-to-peer network, and it would find essentially the IP address of the network interface of the device, and it would use that to initiate that key exchange. And we can talk about the mechanics of that if you want, but
yeah, please do. Actually, I want to hear the details on that. So like you have an IP address, but IP addresses change all the time. So that's not marrying it to any, like that's not going to be part of like a private key or anything. What are you using like to
Correct. Yeah. So taking a step back, there's basically really three chips on the device. The outermost layer is your network interface. So this is essentially a system on a chip that's running Linux. And that's obviously not where we store the private keys. It's not even where we build the transaction logic. So that's what you're pairing with. That's what has the IP address. And that's what allows you to basically make requests to the device. Now, the identifying characteristics of the device are actually the third chip, which is the same chip that you would find on like a credit card. And that's where your keys are stored. That's where the signatures are made. That can only communicate with an app through like three layers of abstraction. The first being the network interface, the second being your HSM, which is where you take requests and you basically parse them through those through those schema types that we were talking about earlier. And only once you've built that transaction do you send it to the chip for signing. But you can think of a transaction as not necessarily just being a payment. It could be sort of a cryptographic signature to sort of authenticate your identity or something like that. So what I would say is that loosely, the concept of identity is constrained to that third chip. And what makes this device even more interesting, I think, is that the third chip also comes on smart cards that we will sell independently. So if you plug a smart card in, or if you go through a multi-sig scheme, then that can actually take over as your identity as long as it's sort of plugged into the device. So if you want to communicate with that, you could then do that with a paired device, but it's sort of an ephemeral identity. And you can think of that as, in all sorts of sort of multi-factor authentication schemes.
Yeah. So to give a little summary of that, so there's the three chips: the secure computing environment, the general computing environment, your outermost layer. Your secure computing environment is one of these secure chips that was originally designed for point of sale systems. So it's hardened against power analysis attacks, side channel attacks. It has the ability to do anti-tamper monitoring. So basically our whole device is wrapped in an electrical mesh, and that electrical mesh is composed of wires that are twice the thickness of a human hair, and it's monitored from the day the device is provisioned to its end of life. So if anyone tries to tamper with the device, cut into it, drill into it, open it, it'll basically brick the device. And then that's actually, that chip right there is kind of the hypervisor of transactions. So when a request is made and the schema is being checked against a permission, that's the chip that's actually doing the checking. And then it's also the one that's actually forming the hash that then gets signed by the third chip, which is the one Alex mentioned from a smart card. We call it the secure enclave. And that's where the key is actually persistent. So that one would actually then sign the transaction, send it back to the secure compute environment, and then send it back to the general compute environment, and then broadcast it out.
So that's interesting to me. So the second chip, the secure compute layer, that's not general compute. It has this very specific purpose. Is this differentiated or similar to FPGA in any way, or is it literally kind of like an ASIC, and then it's like specifically built to do one thing, or how does that work?
So it's not an ASIC. It's a microcontroller, but it's a hardened microcontroller. It's purpose built for kind of secure financial applications. So this one finds its use currently in point of sale terminals. And so it's not an ASIC, it's not an FPGA, it's a general purpose
Sounds
micro.
like a PLC, like a programmable logical controller that they use in like industrial control systems.
Yeah, it's a little bit
It's more akin to that than an ASIC.
Yeah, it has a little bit more power than a PLC, but it only has 256K of RAM, so it's all done in C. It's not a high power thing. All the code that's going on it is something that we're writing and we're reviewing, so it's a very constrained sort of operating set. And then the other thing that we didn't mention actually is we have a physical mailbox between the two devices. So between the general compute environment and secure compute environment, there's actually it's an FRAM or a FRAM. It's this form of magnetic flash memory, and basically that's physically muxed away from the GCE. So the way it's kind of like an airlock, right? So the GCE says, "Hey, I have a message. Okay, I'm going to fill the FRAM." It says, "Hey, I have a message." It tells the secure compute environment that it has a message. Secure compute environment opens the airlock, right? And then the GCE writes to this FRAM. It then says, "Okay, I'm with a separate line." There's the one-line interface. It says, "Okay, I'm done with writing." So then the secure compute environment then reverses the airlock. So then the GCE no longer has access to the FRAM, and the secure compute environment has access to the FRAM, and then it reads that limited set of data out of the FRAM, and then can operate on it. So even that message passing interface, we've kind of made like this airlock so that only a certain amount of data of like a certain type like can get to the secure compute environment when it wants it, and in no other way. So you can't have like overflow errors or anything like that, or buffer overruns, because like you physically only have this 128 bytes of memory here to write to at a time, and the general compute environment doesn't have access to it when the secure compute environment's reading, and vice versa.
So it's sort of like a CDC tent, right? Where you have people coming in who may be infected. You kind of the Linux chip. We don't trust it. We don't trust the outside world. So we want to make sure that there's a clean way to get anything that needs to come to the secure compute. We want it cleaned out, and we want to make sure that it conforms to the schema that we expect.
What I find interesting about all this is that like that all sounds very complex, and people may be scared about it and say like, "Oh, this technology isn't usable." But at the end of the day, like if you look at how just like credit cards work, right? The chips on credit cards, and then the back-end infrastructure associated with transporting that message and handling the messages is also incredibly complex, but people use the living shit out of it, right?
Yeah, and they have no idea how it works.
Like people don't even know they're holding keys on their credit cards and what the chip does. They just say, "Oh, I insert this piece of plastic and money happens."
Exactly. Yeah. So of all this complexity, right? If we're a tech person, right, we can discuss and geek out on the complexity, but from a user standpoint, like you say, you need to know about none of it when it's all put together and done. You just have the magic money box that you stick the magic money card into, and money magically happens, right?
Or don't. So just to clarify one point, there is one of those, or just to reiterate it rather, there is one of those smart card chips baked into the device itself.
Yeah.
So you don't need a smart card, but it's useful for like multi-factor authentication.
And backups and whatnot.
Yeah, and backups
as well as like multiple identities, I'd imagine. Like if you want multiple accounts and for various things, or like multiple people doing different things with different crypto, you'd need those cards to change through that type of stuff.
Yeah. So, I mean, for example, if you're into crypto, you likely have more than one hardware wallet, right?
Yeah, I have quite a few different things stored in different places.
Yeah. Yeah, but what this does is this allows you to kind of have like one central place for your hardware wallets, and then when you want to have different, identities, maybe you have, a business use case for one account, you have a personal use case for another, maybe you have, that use case that you don't want the people to know about on another, whatever that might be. And then, right. And then you also have this concept of backups, which gives you the idea of being able to store your many cards in many different places. So with one device, and essentially an infinite number of abstractable accounts and cards, you can pretty much just have the one device and still achieve all the things that you could achieve with your 10 hardware wallets that you have sitting in different places.
Yeah.
So
there's also one thing I want to just kind of highlight that we haven't really talked about directly, which is that we sort of philosophically, we don't like BIP39. And the reason we don't like it is because if you think mechanically about how you back up, basically how you use a hardware wallet today, right? So you unbox it, it generates some randomness and it spits that out into seed words. And what do? You write those down on a piece of paper in plain text.
No, you take a phone photo of it and put it in your phone Dropbox.
Yeah. and back it up with your iCloud.
So like fundamentally from like a secret storage perspective, it doesn't solve anything. It just pushes the secret to another layer. I mean, admittedly, putting it on a piece of paper may be better than putting it on, your laptop, but it's not that great.
It can solve it, but what it does is it makes it incredibly easy to negate all of the security things you're doing by putting it on a hardware wallet. And it shouldn't be that easy to screw it up.
Well, and it puts the onus on the user. And even as like somebody familiar in the space, it's still very difficult to securely deal with seed phrases, right? Just physically. So, but when you think about the cards, the cool part about the cards is, you could get one of my cards with my entropy on it, and I'd be perfectly comfortable with that. Right. So as long as I've done my due diligence in making sure that I have kind of mitigated my risk through, the use of the accounts that I have and backups that I've made. If you get one of my cards, like I'm not going to lose any sleep at night because I know you're not going to be able to use it. So unlike that piece of paper that's my backup that sort of sits on my counter, one of these chipped cards, if it's sitting on my counter and you get it, like it's fine.
And that's because they're pin protected. We didn't say that explicitly. But
well, so they're pin protected, and the other thing that they have is something called a puff. So either the secret that's on the card will be encrypted by the puff, or you could use the puff directly, such that if you get your hands on the puff and you don't have the pin, you don't have the device, like I don't care who you are, and what technique you want to use. If you want to decap the chip, if you want to, put in a TM, you're still not getting my seed phrase. So it's just a very good way to keep a secret in physical space.
So this is all neat from a decentralized perspective. Like each device is kind of its own little wallet unit, and it contains your own stuff. But there's got to be some sort of centralized component if you're maintaining a marketplace for, say, energy. Or any sort of asset that you're trying to trade using this. I mean, there has to be some sort of reporting features and some way of interfacing with this stuff. And like, how do you know how much is going on in the grid? You can get these smart devices, but I mean, these smart meters, but is there some sort of central reporting or sort of anything about this that has kind of a bottleneck in the central area?
Yeah, so in the energy use case, the centralization is Grid Plus as a rep, right? And that will continue to be the bottleneck until sort of regulation changes that allows us not to be that bottleneck. But presently, there's no way for us to actually allow the customer to directly interface to the market. They'll always have to go through us as a pass-through until sort of the market regulations change. So in terms of the marketplace, we're the centralization for electricity. There is a path that you could use to decentralize that, and you could use lattices, and you could use one of a numerous number of decentralized exchange protocols to effectuate that. But that is a long-term vision that would require us to get kind kind of the rules changed within the marketplace. So.
Yeah, and that makes perfect sense. But so I guess you're settling on the blockchain, right? So we would go through your system, or would they directly interface with the blockchain themselves? You say you're blockchain agnostic. If you want to be open to Lightning Protocol as well as just regular old Ethereum, are you settling on the device itself, or are we going through your system?
Yeah, no. So the device is forming and sending the transaction. They don't.
Okay.
They can set up with whatever node. If they want to run a full node at their house, they want to connect to whatever full node. If they want to run an SPV node, however they want to do it,
Right.
They can do it. So it's the blockchain is independent of us, right?
So let's talk about the happy path then. Everybody starts using your thing. How does that, like the scaling of blockchain systems as they stand right now, probably wouldn't be able to support that quite yet either. You'd have to use things like Infura or set up something like Plasma Chain. What are your thoughts on the current state of blockchain scaling and how you guys plan on interfacing with these kind of alternative layer 2 solutions in the future?
So going back to, what I was saying earlier about how we've designed the concept of schema and permissions, we don't want to be constrained to placing bets on which blockchains and or layer 2 solutions will capture majority market share in the future. We want to leave it abstract, and we want to let users essentially decide what they want to sign with, be that a Bitcoin transaction, a Lightning transaction, Plasma transaction, etc.
Or a state channel.
Yeah. So I guess if you're asking me personally, I'm pretty excited about Lightning. I'm pretty excited about the growth of that network. I think Plasma, there's a lot of stuff on Ethereum 2.0 or whatever it's called these days. I think it's cool, but I think that Plasma actually solves most of the problems related to scaling, frankly. So it's been interesting to see them iterate on those models as sort of the last, 18 months or so have gone on. I remember when Vitalik and Joseph dropped that Plasma paper, I got really, really excited because
Me too.
it was, it was sort of an aha moment. So I think, I've written a few articles on this in the past. I haven't really done any work on it in the last, call it 9 months. So I am a little bit out of the loop because I've been really, really focusing hard on getting this lattice out. But what I think makes the most sense from a design perspective in the Plasma context is that you just have a sort of single operator who's running transactions probably through a database, honestly, and then just collapsing them down into Merkle trees and then committing that hash on the root chain. And I think that is sort of the underlying theme that has persisted across all the iterations of Plasma. Now you run into problems, especially in the earlier designs. You had the mass exit problem where if, the operator transfers all the money to himself and then tries to withdraw it, someone would probably challenge that, but everyone would be like, I don't want to be in this chain anymore. And they would all leave. And then you basically blow up Ethereum. So the way I think they've figured ways to mitigate that, but then you also have this other problem of if you have like a non-fungible asset, and actually I don't know how you would do Plasma with fungible assets, but
Non-fungible.
No, with fungible assets. So the way that the original designs, and the constraint comes from the fraud proof, right? So the original designs were that you take Ether and basically convert it into UTXOs, and then you track those UTXOs on the Plasma chain across all the different Merkle branches. And then if you want to withdraw, you basically select a Merkle branch and make a proof that you received that UTXO. The problem with that, of course, is that if you have to trace, or if you have like a 10-cent UTXO that you have to trace origin on, and it's like passed through 1,000 other people's wallets before it got to yours, is not actually worth withdrawing, right? So I think that they talked about Plasma Prime as sort of, I think they're doing
Yeah, that's like kind of the release that's basically going to handle the majority of the things that they're gathering consensus around. All the naming schemes were kind of a joke that had different one-offs and feature sets of some type of plasma, and they're kind of now coalescing around Prime as the thing they're hopefully moving forward with and stopping with the shenanigans and naming. At least that was the rhetoric around DEF CON.
Yeah, and I think if I remember correctly, watching that talk, and I still haven't looked into this, it's on my to-do list, but they mitigated that problem that I was just talking about of tracing the like long origin by using range proofs, and by constraining these assets. I think they're still non-fungible into like fixed Merkle branches, I believe. Anyway,
hold on, quick question: how did they supposedly deal with the mass exodus problem?
I don't remember that one actually.
Neither do I off the top of my head. We're having Georgios on the show soon to ask these types of questions and see what the current state is, so people can kind of get together on it.
That's my big pick with plasma is that I mean, if they've solved the mass exodus, that's great, but that's kind of like the I guess my biggest catch point.
I remember them talking about it, but I don't remember the conclusion around it.
Yeah. But anyway, yeah, I think plasma is really interesting from like the perspective of, you have this state that's somewhat complicated and you want to mutate it and you want to do it, or you want to change it, not mutate it. You want to, you want to use this thing off chain and do lots and lots of state updates. I think that makes sense. I think state channels are pretty interesting. So I think there are a few projects that are working on state channels, and I'd like to see those in the conjunction of like stable coins like DAI. Another thing I'm really excited about is actually the growth of DAI. And I think it started off when they kicked it off in, like, when was that? 2016 when they first started it?
I want to say that's right.
I was like, they're going to launch this thing. I'm not confident it'll make it like through the weekend. We'll just see if
yeah.
And it didn't. And every day that goes by, I think, is kind of a testament to its soundness. And as the liquidity pool grows, then the marginal cost of like doing that price oracle, I think drops relative to the total supply. So I think it's a really cool. I'll still call it an experiment. I think it's a really cool experiment. And I'm excited to see where that one goes. And then I think it's great that we have these backups like, USDC and whatever the other ones are. So yeah, I think there's a lot of cool stuff happening. I do think we're still a ways away. But it's fun to track the metrics.
Yeah. And I think it's kind of mirrors what I've been doing. I got really excited about all these layer 2 solutions and stuff, but their timelines are a lot longer than I thought they would be. They seemed simple on the surface, but then things started popping up like the mass exit problem.
Oh, it turns out this is hard.
Yeah, right. So like, even though Vitalik and Poon put this paper out, doesn't mean it's solved. It just means that they've got a vision. But what I like about plasmas is the architecture around it. Just the fact that you can build plasma chains under plasma chains and or just plasma mechanisms, which is something else. I mentioned this to you before our interview started. I thought it was really interesting that you took the approach in a blog post a while ago about alternative ways of managing plasma staked value, such as in Kafka streams and in MySQL. And I'm kind of interested in how, once we solve the general case of the chain problem, can that apply to other areas such as RDBMS? And like, I'm excited about those things personally, but I'm with you on that. Like, I can't keep up to date with all that, as I am not a researcher. I have to actually do stuff, and I kind of apply these things in my real life, and so it's good to keep up with when I can. But real life does take over. I definitely am excited for plasma personally. So actually, one question I haven't asked in a while in the program, but I really want to ask you guys: are you philosophically there will be many chains, a mesh net of blockchains or consensus mechanisms out there kind of person, or do you think evolution of just the markets and such will lead to just people selecting one, and that'll be the main source of truth for the entire globe?
So I'll jump on this first.
You look pretty excited when you asked the question there for a moment.
Yeah. So I'll jump on this first. So one of the other things besides the mass exodus problem that I have with plasma is the tragedy of the commons problem, meaning that you don't have a mechanism by which the plasma operators have a requirement really to feed back a lot of value in fees back to the chain. And I think this ties into this concept of, will we have many chains or will we have one chain? And I think that what you ultimately have to have is, we will not have a sustainable chain until we increase layer 1 scaling, regardless of what we can come up in layer 2. And that just has to do with chain security. So I've come up with something that I kind of think of as like this economic ratio of security. And what that is it's the market cap of a chain relative to the amount of money that's spent per day securing that chain. So, I think a reasonable number for that ratio is somewhere between 10,000 and 50,000, let's say. So, if you have $100 billion market cap, you have to spend at least 10 million per day, up to 50 million per day to like secure 100 billion market cap. And where that comes from is that in a truly Byzantine environment, a nefarious actor, if they can execute an attack, so let's say it's $10 million a day in securing the network, if they can execute an attack for $100 million, which means they can roll back a chain, 24 hours later, and they do a transaction with you for $101 million, they could essentially spend $100 million, get, what they're receiving from you for that $100 million, run off and then roll back the chain, and they'll have made an extra $1 million. So that's really kind of like the definition of what security is in a Byzantine environment. We can argue, okay, maybe there's like other mechanisms for enforcing that thing. There's legal systems, there's nation states, there's militaries, but all of those things should be obviated if we do our job building a truly decentralized blockchains, right? So to truly have security in a Byzantine environment, you have to have money being generated in fees to secure the chain. And if you don't do that, you basically don't have a secure chain. You don't have a Byzantine fault tolerant system. So I would argue that the chains that are going to win are the ones that can actually generate more scaling on chain, such that they can generate more revenue to secure the chain, which will support a higher market capitalization and will support a larger valued economic transactions to actually be secure. I don't think that there'll be a single chain, but I do think that you'll probably have a Pareto distribution, because it's sort of like a competitive evolutionary system, and that's how competitive evolutionary systems, manifest. So you'll have, 4 or 5 chains that make up 80% of the value, which is kind of what we already see with, the marketplace as it exists. I think that will continue. But I think the ones that will win are the ones that will actually create mechanisms for doing layer 1 scaling in addition to layer 2, so they can sort of achieve that economic security.
In that kind of framework you just gave, does there have to be an external source of kind of value that's securing the chain? Right now, it's the electric cost of running miners. That's basically the monetary value, as well as the overhead of operating those ASICs, and that's an external source being pumped into the securing of the chain.
Yeah, so I think you do need an external source of value. There's and some of this kind of gets into sort of like some ideological arguments between proof of stake and proof of work. One potentially, I would say proof of stake, if you sort of run down it, there is value, quote unquote, being put up, and that's the cost of money. But the problem is, because if 2 chains fork, you have nothing at stake. So really what proof of stake turns into is social consensus. The difference being in proof of work, that if a chain forks, I have to uniquely vote with my money on where I'm putting my hash power, which is not true with proof of stake. So that's which makes it not social consensus, but rather an economic consensus. So I'm definitely kind of in the proof of work camp. In terms of the external value, it can be anything, right? It doesn't have to be electricity, right? Other people have come up with the concept of proof of storage, right?
Yeah.
But really what proof of storage is there's energy that goes into making a hard drive, which you then have to amortize over the life.
It's a
of the
scarce physical resource. That's
correct. You're going to have to do some use of a scarce physical resource in some provable way on a blockchain to maintain economic security and not social consensus. If you think about the Federal Reserve is social consensus, right? It's all the big bankers with all the money got together and say, hey, we're going to dictate what the money supply is. You could absolutely see that devolving into the same thing under a proof of stake system on a blockchain.
Well, let me turn that around. Like, I agree that you need to tie some sort of scarce resource, but I would make the argument that the scarce resource in a proof of stake environment is actually labor, meaning that the applications that are built on the chain itself give that chain value. And that social consensus is just another way of framing the scarce resource of labor and development and use of the chain. So I would actually argue that both cases have some sort of scarce resource which is tied to it.
But it's not though, right? Because if I fork Ethereum, let's say, I can take all of that sort of work with me because these are open source distributed systems and all those applications. I just need to convince people to come with me. So that's a social process. That's a political process.
And that's no different than convincing people to use the hash power on a different chain.
No, it's completely different because they have to uniquely vote, right? In a proof of stake system, I can hedge out, right? I can keep staking on two different chains.
the cost of switching is negligible in proof of stake, so you could
Well,
possibly
the thing
both.
is that the value itself
I don't have to uniquely vote is the point, right? I can continue voting and staking with my monies from both chains.
Yes, but if your user base is still stuck on this other chain, like you're going to have to make a decision. Like that's what it will ultimately come to, is where is the value of the users? If the user base is specifically looking in one particular direction.
What truth are they referring to,
where
basically?
is the value of your labor? Your labor's value is going to be in the social consensus side.
I think what Carl's saying is that as a block producer, which is the analog of a miner, right? If I'm running Ethereum software on my laptop, I can probably run 2 instances of it, right? And I can continue to produce blocks for both chains until such usership has basically chosen one, and I can continue to profit off of producing
or potentially profit. There's no choice you have to make to point your validation software, whatever that be, whether it be an ASIC miner or a proof of stake node, at one particular blockchain, because it can only do one at a time. The overhead associated with doing multiple at a time is not big enough to have to choose.
Yeah, correct. So as a rational economic actor securing a chain, unless I have an ideology or a social tendency, I will keep staking on both, right? So like implicit in that idea, that's social consensus. It's politics again. So we're reintroducing politics into what's supposed to be apolitical money.
It's an argument.
That's a strong point.
Well, and anyway, I just have to mention something because we're getting down this path. So I published a kind of a paper just outlining a concept called block reduce, which is a way to scale proof of work chains to basically meet, humanity's transaction throughput. So, 50,000 plus TPS. I would love it if one of the core devs would take a thorough read of it and consider looking at that for a level 1 solution to Ethereum.
Well, we will use whatever weight we have to try and get that happen. I don't know how much weight that is, but
yeah, it's available on archives if you just
I'll put it in the show notes. How about that?
Google it. Yeah. But anyway, I mean that's right, and this comes back to the idea of like what we're doing with the Lattice 1.2, right? So like, I would love it if we could stay on a proof of work system, because I think proof of work is not like a social consensus mechanism, and it will actually kind of realize like free economic money, right? That's so proof of work and proof of stake in my mind is similar to like the Lattice and Coinbase, right? So the Lattice, if we decentralize things, we can disintermediate intermediaries, but people are actually in control of their money. So we're moving towards that like free, system. And I would think that the same thing is true if we can scale proof of work over proof of stake. I think that's more sort of free than if we go down the proof of stake path. So freedom on both sides is kind of what I'm shooting for.
I'm curious to see how all this develops over time. I mean, it's one of those things that I don't have strong ideological reasons either way. I want something that works, that gives exactly what you're looking for, and I'm trying to find out what that's going to look like by talking to people like y'all. Yeah, like anything else that we didn't get to ask you that you definitely wanted to talk about?
Yeah, no, we appreciate it, guys. I think that was a fun conversation, and I do really encourage people to think about, like, as they're building systems. I think ideally in the world of blockchains, we have to think of ourselves as a little bit differently than traditionally in business, and that, as the technologist, what we're really trying to do eventually is build a utility, and a utility should be free and open to all, rather than build this business that will perpetually take a fee. However we can effectuate that as technologists, I think, one, it'll make you ultimately more successful, but two, I think it will realize the sort of vision of what we hope sort of, free, fair, economic digital money can be. So.
Awesome.
Thanks, guys.
And for the listeners, if you like this, hit the subscribe button on whatever podcast platform you use. We should be on all of them. Share it on Twitter. Share it on everything. Share it everywhere. Tell your friends. Tell everybody.
You can find us at hashing it out.
Yeah.
Hashingitout.stream,
or you can go to thebitcoinpodcast.com and click on podcasts or shows, and it'll be under there. Join the Slack on thebitcoinpodcast.com to talk with us, ask us questions, ask us about guests, so on and so forth. So thanks for coming on the show, guys. I greatly appreciate it, and can't wait to see Lattice Ones and everybody's home. I'm going to have one.
Yep.
Appreciate it, guys.
Thanks, guys.